If I place the first plate, that should be removed last. Which plate is last inserted, that should be removed first. Which plate is first inserted, that should be removed last. Which is the real life example for the stack? Pile of plates on the dining table. Last in first out manner. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the stack operations? Push, pop, display. Push is nothing but insert an element into the stack. If you want to insert the new element into the stack, it is called as push. What is meant by pop? If I want to remove the element from the stack, the deletion element from the stack is called as pop. What is meant by display? Whatever stack you are already created, the list of elements to be displayed. Top to bottom, all elements to be displayed. Whenever push function is possible, if the top indicator less than or equal to size minus 1, push is possible. If the top is less than or equal to size minus 1, you can insert the elements. Whenever top is greater than size minus 1, push function not possible. It is shown the error stack is overflow or stack is full. Whenever pop operation is possible, if you delete element from the list, that is pop. If the top equal to minus 1, stack is empty. Top equal to minus 1 called as stack is empty, there is no elements, you can't remove. If the top is greater than or equal to size minus 1 or top is greater than or equal to 0, whenever top is greater than or equal to 0, you can pop the elements. If the top equal to minus 1, there is no element, stack is empty. It is called as underflow. When you display the stack elements, if you have at least one element or more than one element, then only you can display. If the top equal to minus 1, stack is empty, there is no display. Finally, what are the functions can be used? Push, pop, display functions. What is the drawback of the stack? Drawback of the stack, anywhere you can't insert the elements, anywhere you can't delete the elements, top position only to insert the elements, top position only to delete the elements. At topmost only to insert elements, at the topmost only you delete the elements. What is one more kind of data structure in C programming language? Queue data structure you have, queue. What is meant by queue data structure? FIFO manner, first in, first out. Which element is first inserted, that should be removed first. Order wise, first element will be first remove, second element is second remove, third element is third remove. It is a queue manner. Whenever some persons are standing on the queue, any tickets counter, some persons are standing on the queue, the first person taken the first ticket and quit from the queue. Second person taken the second ticket and quit from the queue. Which person is last stander, that person taken the last ticket and quit from the queue. What is the operation of the queue here? First in, first out manner. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Suppose my queue size is 5 elements. I can insert 5 elements. Suppose if I want to insert back, what is meant by back here? Rare index. Every queue can perform with 2 indexes. One is for front, another one rear. Front is nothing but which is the first position element, that is front. Front index is 0. What is meant by rear? Which is the last element in your queue, that element is called as rear index. Front equal to 0 index, rear equal to size minus 1. If my queue size is 5, 0 to 4. 0 is the front index, 5 minus 1, 4 is the rear index. If you want to insert the new element into the queue, where you can insert the new element? Rear position you can insert the elements. the new element inserted at rear. If I want to delete the element from the queue, front position to delete. Deletion at the front, insertion at the rear. Whenever you are insert the new elements into the queue, which to be increment? Rear plus plus. If you are insert the element into the queue, rear index increments, rear plus plus. If you are delete the elements from the queue, which index to be increment? Front plus plus. If you remove the elements from the queue, front plus plus, front index to be increment. If you insert the elements into the queue, rear plus plus, rear position increments. Finally, what is my conclusion? The queue is a data structure. It's a linear data structure. Queue is also linear data structure, line by line to store the elements. Line by line to store the elements. It's a FIFO manner, first in, first out. Which element is first inserted in your queue, that should be removed first. Which element is last inserted into the queue, that should be removed last. Stack is a LIFO manner, last in, first out. Which element last inserted, that to be removed first. But the queue is a FIFO manner. What is the way you are inserted? Same way to delete. Stack, which is the way you are inserted, reverse way to remove the elements. But the queue is which is the way you are inserted, same way to remove the elements. What are the queue functions you have? Insertion, deletion, display. Stack also function, push, pop, display. Queue is also you have the three major operations or three major functions: insertion, deletion, display. What is meant by insertion? If I want to add the element into the queue, which queue is already there, if I want to add the new element into the queue, that is called as insertion. Insertion positioned at rear. Which element I want to remove from the queue, it's called as deletion. The deletion at front. Insertion time rear plus plus, deletion time front plus plus. One more function you have, display. How to display the queue elements? Front is equal to 0, rear equal to size minus 1. Front to rear, all elements to be displayed one by one, front to rear. Whenever insertion not possible into the queue, whenever insertion not possible, if rear reach to the rear is equal to size minus 1. Whenever rear is equal to size minus 1, queue is full. Whenever rear is less than or equal to size minus 1, you can insert the elements. Whenever rear reaches to the size minus 1, queue is full. Whenever deletion not possible, if the front equal to rear equal to minus 1. What is meant by front equal to rear equal to minus 1? Initially for the queue there is no elements. Whenever the queue no elements, there is no deletion. Front equal to rear equal to minus 1 called as, it's empty, queue is empty, there is no elements, you can't delete. Whenever deletion is possible, if the front equal to rear equal to greater than or equal to 0, less than or equal to size minus 1, greater than or equal to 0, you can remove the elements. Whenever display function possible for the queue, if the front or rear 0 or above 0 index, at least one element or full elements, then only you can display. If the queue you have the at least one element or full elements, then only display. If the queue there is no elements, there is no chance of display. You can't display the elements because the queue is empty, underflow. Now every queue, what is the problem? Every queue, insertion at rear, deletion at front. Again, what is the drawback of the queue? It's a linear queue. Linear queue drawback, insertion at rear, deletion at front. Anywhere insertion, anywhere deletion not possible. Anywhere you can't insert the elements, anywhere you can't delete the elements. Stack is only one end you have. Top only insert, top only delete. But the queue you have two indicators, two ends, front, rear, front, back. What is a real life example for the queue? Everywhere queue follows. If you want to move the car, within the queue only cars will be there. First car will be moved. After that second car will be moved. Queue on the queue. Whenever the cars are in the queue now, first car will be first quit, second car will be second. Tickets counter also standing the person's queue wise. Which person first standing, that should be take the first ticket and from quit from the queue. Which person is last standing, that should be take the last ticket and quit from the queue. What is the drawback of the queue operations? Insertion, deletion are not possible anywhere because it's a linear list data structure. Finally, what is the definition of queue? Queue called as linear list. Queue is similar to array, list of elements, FIFO manner. It's a process of FIFO, first in, first out. What are the queue functions we have? Insertion, deletion, display. Queue can be implemented with arrays. Queue can be implemented with pointers. Queue can be implemented with linked list. Queue can be implemented with array. Array means fixed size. Queue can be implemented with pointers, dynamically used. Queue can be applied with linked list, list of elements, link of elements. You see that now while working of queue, what are the definitions? Will be move on to the queue. Queue is nothing but abstract data structure. Queue is nothing but abstract data structure. It is similar to stack. But unlike stacks, a queue is open at both ends. Stack will be only one end will be there. One end is closed, one end only open. But the queue is open at both ends, front, rear. One end always to insert data, one end to be insert the data. That insertion called as enqueue function. In the stack, insertion called as push function. In the stack, insertion called as push, but in the queue, insertion called as enqueue. In the stack, deletion called as pop, but in the queue, deletion, removing called as dequeue, deleted queue. Now for the queue, one end for insertion, another end for deletion. But in the stack, same end insertion, same end deletion. Top only insert, top only delete. Queue insertion called as enqueue, queue deletion called as dequeue. Now the queue will be follows which manner? First in, first out. Which element is first inserted, that should be removed first. That will be accessed first. In the real world example, queue can be like anywhere, single line or one way. Whenever you take the on the road one way, you have all vehicles are one by one enter the and one by one exits. Whenever you have the one way route, which vehicles are first enter, that should be first exit. Which vehicle is last entered, that will be exit last. It's a FIFO manner. In the real life example, many you can take the queues, tickets window, ticket counter or ticket window. At bus stops also, it's followed by queue mechanism. Now, if you understand this queue, you have the both ends, two different ends will be there. It is open, two different ends will be there. You see that whenever you are working with a queue, what is the diagram can be understand for the queue, check it. The queue is it's a vertically data structure you have vertically represent. Stack is horizontally it will be there, but the queue is it's vertically you can represent. Now suppose this is my queue. This is the diagram can be implemented for queue. Suppose my queue name queue, my queue name is queue of 5. Queue of 5 means 5 elements. Every queue two indicators, I mean 2 indexes you have. First index you called as front. The first index is called as front index, front. It's called as front equal to 0. The last index, I mean rear index, back. Rear equal to size minus 1, rear is 4. Initially there is no elements on the queue at the time. What is my statement? Initialize. Front equal to rear equal to minus 1. front equal to rear equal to minus 1, it's called as, whenever I indicate this front equal to rear equal to minus 1, it is called as front equal to rear equal to minus 1, that is called as Q initialization. Front equal to rear equal to minus 1, it is called as empty. Currently the Q is empty, there is no elements. Every Q one by one to insert the elements. Suppose first I am inserting 10, suppose next I am inserting 20, suppose next I am inserting 30, next I am inserting 40, the Q elements one by one insert. When I remove these, first 10 will be removed. In this Q, if I want to remove the elements, which will be removed first? 10 elements. Which element is first inserted, that should be removed. Whenever I remove this, the front will be moving this position. Front is moving to next, front plus plus. If I remove that, again moving on that next, front is moving on this. If I remove that, next I want to, front is moving on this position. If I remove that, front is moving on the next position. If I remove that all elements, the front and the rear equal to minus 1. Whenever all elements are removed, front and rear equal to again minus 1. Whenever insertion time, if I want to insert elements, this is deletion operation. If I want to insert element, how it is inserting now? First 10 inserted, first 10 inserted. Whenever I inserted the 10, front, rear both are same position. At the time here rear is not available, because in my list only one element I inserted. At that time, whenever the Q only one element I inserted, at that time front, rear same position, front, rear 0 only. After insert this element, second element, when I insert the second element, at that time which index will be move on? Rear. Rear index will be move on. Now rear plus plus. After that, if I insert the 30, insertion at 30, at that time again rear index will be increments. It is moving on rear index will be increments. If I insert the next element, again the rear index will be increments. If I insert the next element, again the rear index will be increments. Every time rear will be move on. Insertion time rear will be move on, deletion time front will be move on. Now you see this is also for rear will be increments. Insertion time, if I insertion that, at that time which will be move on? Rear plus plus. If I want to delete the elements, which will be move on? Front plus plus. One is for front plus plus, another one rear plus plus. Whenever front equal to rear equal to minus 1, Q called as empty. This is the operation, first in first out manner to make a Q, front and rear. Now see that while working off the Q here, which are the basic operations I discussed? See, NQ. NQ will be there. What is meant by NQ function now? If I want to insert an element into the Q, is called as NQ. If I want to add the item into the Q, called as NQ. Next one is DQ, you have deletion Q. If I want to remove the element from the Q, is called as DQ, deleted Q. Few more functions required to make above mentioned Q operations, NQ and DQ. Peak function is required. What is meant by peak function? Which is the very beginning element. That is called as front. In your Q, which is the front element, very beginning element, without removing it, that is called as peak. Peak is called as front element in your Q. Is full function. What is meant by is full function? Whenever Q reaches to the size minus 1, rear reaches to the size minus 1, Q is full. Actually, my Q size is 5. My Q size is 5. Initially, rear is 0. After insertion, rear is 1. After that, rear is 2. Rear is 3. Rear is 4. Whenever rear is reaching to size minus 1, there is no insertion. Insertion not possible. At that time, is full. One more is there, is empty. Whenever is empty, check if the Q is empty or not. Whenever I delete the 1 by 1 elements, first 10 deleted, next 20 deleted, next 30, next 40, next 50. Whenever all elements are deleted, there is no deletion function. Whenever front and rear equal to -1, there is no deletion. If the queue is empty, there is no deletion. If the queue at least one element or full elements. If the queue at least one element or full elements, we can remove. If the queue is empty, there is no deletion. That is called as isEmpty function. Now we always dequeue pointed by the front pointer. Every deletion is front position, and if you want to insert the elements, every time always nq. It is called as which pointer? Rear. Dequeue function working with the front. Dequeue function working with front pointer, nq function working with the rear pointer, back of the queue. You see that if I want to work with a program of this queue operation program, check it. stdio.h, standard input output header file, string.h, strings can be done, string length, string lower upper, stdlib.h, standard library, and std boolean type also use, boolean functions. Hash define max 6, size of your queue. Hash define is macro, size with 6. Int array, queue array, size is 6, queue array. Initially front is 0, rear equal to -1. Initially front I assign with 0, rear equal to -1. Our item count equal to 0. I mean how many items I have. What is my first function? Peak function. Peak. Whenever the queue will be display as peak, in your queue first element called as peak. In your queue front element called as peak. Initial element called as front element called as peak. Return the front. Return the front. Int array called as array. Return the front. Whenever boolean is empty function is empty. Whenever queue is empty, item count is 0. There is no elements. Whenever return boolean is full, item count equal to max or max -1. Whenever the queue position item count is 0, there is no elements. Whenever the item count is maximum size, queue is full, boolean type. I want to find out size of my queue, return the item count. Suppose my queue have the 5 elements, what is my size? 5. If my queue has the 10 elements, what is my item count? Return 10. What is the logic of insertion? Insertion, how to run off that? Insert, void insert, data, I mean element to be insert. Insert function, insertion, nq, data to be insert. Whenever insertion is not possible, whenever insertion is possible, not is full. If the queue is not full, insertion possible. If the queue is not full, insertion possible. Rear reaches to max -1. If the queue is full, at the time insertion not possible, not full. Whenever rear equal to max -1, rear assigned to the -1, I mean empty. Int array plus rear, I mean rear increments, pre-increment. First increment the index rear, then store the element. Data means element. What is the logic here? Rear equal to max -1, rear equal to -1. Max -1 means you are reaching at last element, rear assigned to the -1. If it is not pre-increment, rear should be increment index, then store elements. Item count plus. How many elements you can count? Remove data. Whenever remove the element, deletion, front element to be removed first. After that front increments, next element is moving on front. First element remove, then moving on next. Second element removing, then moving on next. Whenever front reach to the max size or max -1, front 0. Whenever front reach to the max, all elements removed, front initialize 0. Item count minus. I mean totally how many elements are there? Item count minus. If I remove that, count value decrements. If I insert that, item count increments. Return the data, return type. Now you see here, insert 5 items, insert 3, insert 5, 3, 5, 9, 1, 12, order wise inserted, order wise inserted. Now front is 0, rear is 4, because 5 items. Now this is for 0, 1, 2, 3, 4, this is 3, 5, 9, 1, 12. If I insert 15, where it is inserted now? After 12. Whenever queue is full, what is the message? Queue is full. If I want to remove one item, first element remove. Which element is removed? 3. Front position element is removed now. At that time, 3 will be removed. Now rear is at 5. Now here, this is the front, this is the rear. If I want to insert 16, after 15 it is inserted now 16. After 15, whenever queue is full, element will not be inserted. 17, 18, like that also I can insert. At that time it is shown the error, because you are already inserted the element. I want to print which is the front. Peak is nothing but front element return. Whenever queue is not empty, then I want to remove the data. Queue is not empty, then remove. This is basically queue operation, queue functions we have. You see that now while working of queue, now here insertion NQ, deletion DQ, and display, these are the major function. Suppose you see that if I go for the queue, it's a linear list, the display the elements order wise you can display the elements. Suppose my queue size is 4 size, it's a vertically you can arrange the data. My queue is my array name, queue of 4. Initially front and rear I used with -1, it's called as is empty, initialize. After that I want to go for function. What is my first function I want to use? NQ function. NQ means insertion, insert the elements. Suppose I want to insert 10 elements. In my queue I want to insert 10 elements. Now the initially queue is no elements, I want to insert the 10 elements. How to insert of that 10 elements? Now here I want to insert. Now I want to insert these queue elements to be insert one by one. First I want to insert with the 10. Under queue I want to insert the 10 elements. That is inserted at the front position. Now 10 it is inserted. After insert that front equal to 0, at that time rear position also 0. Front is 0, rear is 0. Now I want to insert at 11. I want to insert at 11. 11 I want to insert. When I want to insert the 11, at that time also the next position, I mean rear increments. Rear will be increments. Here every insertion time which to be used? Plus rear increments, pre-increments. Now here 10 inserted, after that 20 inserted. Now this is front position. Now this is front. Now which will be moving on? Rear will be moving on. Now here rear will be moving, rear will be increments. Now here front, rear, previously this position. Now front, rear, this position. Now it is increments. Rear will be moving on this location, rear increments. How it is increment of this here? Plus rear. After that I want to insert the next element now. What is my next element I want to insert here? Suppose I want to insert 30 element. Next is 30 element I want to insert. 30 I want to insert. At that time then you have to use with the next element insert 12. I want to insert 12. At that time also rear will be moving. Now here rear will be moving here, rear increments. Which element is inserted here? Here I inserted with 12. Here I inserted 12. Previously not 20. I changed the elements. Now here this element is, now here this element is 11. Second element I inserted 11. 11 I inserted, this is 11. After that third element is 12, 12 element I inserted. Second element is 11, third element is 12. That position I insert the elements. Order wise it is insert the elements. Rare will be moving. Now I want to insert that next element I have. I want to insert the last element, fourth element. I want to insert that fourth element. This is my fourth queue position index I want to use. Fourth element I want to insert. Now I want to insert that next element now. Here I want to insert this position to insert. Which element I want to insert now? 13. 13 I want to insert. Insert 13. Now the rare will be moving on. Here 13 will be inserted. Now I want to insert next 14, but that is not possible because 13 is reached to the rare maximum size. Here front rare is 0, here rare is 1, here rare is 2, here rare is 3. Whenever rare is equal to size minus 1, stop there. If what is my condition? Rare equal to size minus 1. Whenever rare equal to size minus 1, which message to be print? Queue is full. Queue is full. There is no insertion. Queue is full. Else, if it is not, plus plus rare, rare increments. Here I want to insert queue of index, queue of index position equal to what to be used, or here I used a queue of rare, rare index equal to element or data. Now this is the logic of insertion logic. Whenever q equal to size minus 1, q is full, rare equal to size minus 1, q is full. Else pre-increment, rare pre-increment, rare position index data. This is the logic of insertion, NQ function logic. If I want to go for deletion, if I want to work with the deletion of this, how to delete of that q elements? DQ function. I want to go for deletion now, DQ function to be used. Currently I have the 4 elements in this queue. What is my queue? Queue of 4 size. Already I inserted some elements 10, 11, 12, previously I inserted 12 and 13. What is my front position here? This is front. Front is at 10, rare is at 13. Now I want to go for next function DQ, deletion queue. DQ called as deletion queue. How to delete that? I want to delete 10. I want to delete at 10. That means what? And in your queue 10 element will be deletes. In your queue, which is the first element, that is first deletes. Queue means order wise. Which element first inserted, that will be delete. I want to delete at 10. When I delete the 10, front is moving on this side. Front moving, front increments. Deletion time front plus plus, front only increments. Insertion time rare plus plus, deletion time front plus plus. Now I want to insert that next I want to delete that again. I want to delete that next element 11. 11 I want to delete. Now I want to delete this 11. In this position I want to delete the 11 now here. Delete 11. Second element to be delete. Previously front is at moving at 11. Now 11 also deleted, that is moving at 12. Now this is 10 is deleted, then 11 is deleted. Now the here front is moving. Next I want to delete at next element I want to delete. Next element I want to delete the 12 element I want to delete. I want to delete at 12. Now here I want to delete at 12. 12 element I want to delete. Previously I inserted with 11, here 12 I want to delete. When I deleted the 12, now here I want to delete this. This I want to delete. This position to delete the element. 12 is deleted. Whenever 12 is deleted and this is moving, front is moving. Every time front only increments, front plus plus. Every time front only increments, front plus plus. Front index only increments. Now I want to delete at 13, the last one. I want to delete at 13. Last element I want to delete. Now I want to delete at last element. At the time, all elements I deleted here. Whenever I deleted with all elements, all element. I want to delete at 13. At that time all elements are deleted here. At that time what happened? Fronter rear equal to minus 1. All elements deleted. At that time fronter arrow should be assigned to the minus 1. Whenever all elements are deleted, what is the function logic here? If front equal to rear equal to minus 1, front equal to rear equal to minus 1, printf. What is the message? Q is empty, there is no deletion because all elements are deleted. Otherwise you want to delete that data equal to Q of which index to be delete? Rear, not rear. Front index element to be delete. Front index element to be delete. Front plus plus. Front index increment. This is the logic. Whenever front equal to rear equal to minus 1, Q is empty. Data equal to Q of front increments. If I want to display the elements, front equal to rear equal to minus 1, there is no display. Whenever front is greater than 0, rear is less than minus 1, display possible. This is called as DQ function, deletion to be processed. Finally, what are the data structure? Q data structure I discussed. Now the Q data structure similar to stack. Stack is a LIFO manner, last in first out. Q is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Q insertion called as NQ function, Q deletion called as DQ function. Insertion possible at a front, insertion possible at a rear, rear plus plus, deletion possible at a front. Which element is first inserted, that should be delete first. Front moving, based on front only to delete. Insertion is at rear, rear plus plus, rear increments. Whenever front equal to rear equal to minus 1, no deletion. Whenever rear is equal to size minus 1, whenever rear equal to size minus 1, Q is full, there is no insertion. If the front equal to rear equal to minus 1, there is no Q elements, no display. What is the drawback of the Q? Anywhere you can't insert the elements, anywhere you can't delete the elements. Front only delete the elements, rear only insert the elements. Stack you have only one end, top will be there, one end is closed, topmost only insert element, topmost only delete. But the Q have the two ends, both directions, one is for front, another one rear. Front is nothing but deletion, rear is nothing but insertion. But anyway, stack also, Q also, both are linear data structures, linear. Stack is LIFO manner, Q is FIFO manner. What are the stack functions? Push, pop, display. Q function NQ, DQ, display. What is a stack? Real life example, pile of plates on the dining table. Q means everywhere. If you have the one way on the road, every vehicle, which vehicle first will be placed, that should be quit from the queue. Which vehicle is last place, that should be quit from the last. Tickets counter also you can example. Okay, this is the discussion about Q data structure in C language. In the next session I discussed one more data structure concept, linked list, how to store the elements in the linked list manner. In the next session I can continue. Thank you for this video. Hello students, welcome to the C language training program. Today I want to discuss about linked list in data structures. C language data structure, what is the need of linked list, why you have to use the linked list, what are the advantages of linked list. Now see, the last session I discussed which is the data structure, Q data structure I discussed. Under data structure you have different type of data structures, stack, queues. Stack is nothing but last in first out. Which element is last inserted, that to be removed first. Which element is first inserted, that to be removed last. Queue is also one type of data structure. It is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Stack is a LIFO manner, last in first out. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the stack operations? Push, pop, display. Push is nothing but to insert an element into the stack. Pop is nothing but to remove the element from the stack. Display is nothing but to travel the elements from the starting element to ending element. How to make the operations of stack based on the top index. Which element is first inserted, that is the top index. If I inserted second element, top index increments. If I insert the third element, top increments. Every insertion time, top increments. Every deletion time, top decrements. Decrement the top. If I have 3 plates are there on the dining table, if I want to place the fourth plate, top of the third plate you want to insert. If you want to remove the plate from the dining table, which is the topmost plate, that should be removed first. Top only to insert, top only to delete. What is the drawback of stack? It can be worked with arrays. And one more problem, one end only insertion, same end only deletion. Top only to insert, top only to delete. One more data structure you have, queue data structure. Queue is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Which are the queue operations? NQ, DQ, display. NQ called as insertion element into the queue. DQ called as deletion element from the queue. Display called as to traverse the elements front to rear. Every queue 2 indicators we have. One is for front, another one is rear or back. First element index is called as front, last element index is called as rear. Front position to delete the elements, rear position to insert the elements. Every NQ operation possible at a rear, insertion at rear. If you are insert the new element into the queue, rear increments, rear plus plus. Every deletion, DQ function, front position to delete the elements. Once you remove the element, which to be increment, front plus plus. Insertion time, rear to be increment, deletion time, front to be increment. If I want to display the elements from the queue, front to rear. Front index is 0, rear index is size minus 1. Front to rear to display the elements. What is the drawback of the queue? Anywhere insertion not possible, anywhere deletion not possible. And one more drawback of the queue, queue is a array manner. Generally array is nothing but static memory allocation. Once you fix the size of queue, you can't increase the size, you can't decrease the size. What is the drawback of the stack and queue? Stack and queue drawback, anywhere insertion not possible, anywhere deletion not possible. Insertion is at rear, deletion at the front. And one more drawback, stacks and queues are static memory allocations. Static memory allocation means once you fix the size, you can't increase the size, you can't decrease the size. That is the reason one more data structure is introduced in C language. The data structure called as linked list manner. Linked list is one of the data structure to store the data in the form of list. What is the advantage of linked list? Anywhere can insert the elements, anywhere can delete the elements, anywhere you can display the elements. The main advantage of linked list, insertion at anywhere, deletion at anywhere, display the elements from the first to last. One more advantage, linked list dynamic memory allocation. While working of linked list, dynamic memory allocation. What is meant by dynamic memory allocation? Now dynamically you can create the list, dynamically to add the elements. That means dynamically you can increase the size, dynamically you can delete the size, decrease the size. Once your usage of memory, you can delete the memory also. You can create dynamic memory allocation functions you can create. Malloc function, calloc function, free function, that you can operate with the help of linked list. Dynamic memory allocation possible with help of pointers. Pointer variable should be created. Finally, what is my conclusion? Why you have to go for the linked list? Advantage of linked list: insertion, deletion, display anywhere. You can insert the element at the front also, rear also, middle also. Deletion also at the beginning also, ending also, middle also. One more advantage, dynamic memory allocation. Once I create the size 2 elements, but later I want to increase my size, possible. You can decrease the size, possible. With the help of dynamic memory allocation functions, malloc function, calloc function, free function. Linked list possible using pointers, with the pointer only to create the linked list. Actually, what is the definition of linked list? List is nothing but store the elements. Linked list is nothing but store the elements and link to the next element address. One list is store the element and it is represent next element address. Link between the two elements. How to link off the in between the two elements? Pointer should be created. How to define the linked list? List of elements linked with the help of pointers. Linked list is a dynamic memory allocation. Linked list insertion, deletion, display anywhere. Linked list how to create with the help of pointers. You can create with a next pointer, previous pointer, element. Linked list types are there. Types of linked list is there. Single linked list, one-way direction to be travel. Doubly linked list, two-way direction can be travel the elements. Circular linked list, it's a circular manner. Any node to any node you can travel. Link of the chain, circular linked list. Any node to any node you can travel. Single linked list, doubly linked list, circular linked list. Finally, what is my conclusion? Why you have to go for linked list? Once you create the linked list, the list of elements are stored and that is linked with another list element. That is nothing but one element linked with another element. It's a chaining manner. Pointer will be created. Linked list anywhere insertion possible, anywhere deletion possible. It's a dynamic memory allocation, memory saving. And one more advantage, easy to travel, either front to back or back to front. Left to right can be travel, right to left can be travel. The types of linked list are single linked list, one-way direction to be travel. Doubly linked list, two-way direction to be travel. Circular linked list, it is similar to doubly linked list, but the last node pointing to the first node address. Circular linked list, any node to any node to be travel. The last node link connected to the first node pointer. See that how it is works of linked list. Now I want to discuss about linked list. Under C language data structure, linked list to be discussed. Now see the linked list, every list how to represent node. Under linked list, how to represent your data node to be created. Now this is called as node or list, node or list. Every node, if I go for singly linked list, every node two partitions. If you go for singly linked list, you can go for two partitions. It is called as node. I represented it is called as node. Now this is for what? Data to be stored. Now this is for what? Star pointer. Address of the next element. Now every node two partition you have. This is called as element to be represent, and this is called as pointer. It is pointing to the next element address. This is element or data. This is pointing to the next element address. If you go for doubly linked list, the node will be represent three partitions. If it is singly linked list, node will be represent two partitions, element and pointer to the next. If it is doubly linked list, three partitions, data, and this is called as what? Star pointer. It's a left side pointer, and this is also called as another pointer, right side pointer. Now three partition you have. This is also called as node, but doubly linked list three partition. It is called as left pointer, left element address. This is called as right pointer, right side element address. This is called as element. Now this is the representation of singly linked list. Each node represent two partition, data plus next node address, its pointer. And for the doubly linked list, three partition for node. This is called as previous pointer, this is element, and this is next pointer. And for circular also the same way, but the circular, the last node can be connected to the first node, which is the last traveling pointer that will be connected to the first node previous pointer. Now see that how to create the nodes. Linked list, you have three types are there. First I represent singly linked list. How to represent the singly linked list? Singly linked list or single linked list. Singly or single linked list. How to represent that? Suppose I taken with three nodes. If I represented with three nodes, here I have three nodes are there. Three nodes I represented. These are called as nodes. This is called as nodes or list. Now this is my node 1. What is my name of the node? A. Node A. This is my node B. This is my node C. I given the name node A, node B, node C. Now I want to represent